Hi, everyone. Hello, this is Rita from XGeeks. It's great to see you again. I'm super excited. As you know, I think you feel the excitement every time we have our live streams here in our YouTube channel. But it's super nice to have you here once again. So before anything else, if you're new to our channel, welcome. We're super happy to see you here, and we hope to see you again in the future. And if you've been in some of our live streams before, it's great to see you again. And if you're watching this in the recording afterwards, this is awesome indeed. So you can also feel free to join our future events or leave comments or follow us in our social networks. And just to let you know, this is, as you might imagine, initiative promoted and powered by XGeeks. And let's talk about XGeeks very shortly. XGeeks is an engineering company focused on providing capacity to product companies. We're not the typical project company due to several reasons, and that could be a talk just by itself. However, let's leave the stage to our speaker of the day, which you'll meet in a few seconds. But we have a huge focus on community, a strong engineering culture, and product drive. XGeeks represents the balance between projects and products, and our teams across Portugal work in building products while dealing with a broad stack. And of course, if you want to know more about XGeeks, our team, our propositions, our content, and other topics, you can feel free to follow us not only on YouTube, and we're almost reaching the 200 milestones for in terms of subscribers, but also in our Instagram, Medium, and LinkedIn. We do some cool stuff there, at least we hope so. So you can feel free to follow us there as well. Today, no further ado, I want to introduce you to our speaker, which is Roberto Cortes, the one and only. Roberto is a professional Java developer working in the software development industry for more than 10 years. So a lot of great insights, I bet. And Roberto has mostly been working with enterprise technologies and been involved in the community, not also by spreading knowledge with his blog, but also YouTube channel, and also with open source contributions. So a lot of great stuff to be shared indeed. And Roberto will give a talk about Kubernetes, native Java with MicroProfile and Quarkus is the title of this talk. And I could give you the brief introduction of it all, but I want, of course, to move the stage, and let's get to business and move the stage to Roberto. And again, Roberto will be available to answer questions not only during the talk, but also after the talk, so you can feel free to join us and to leave some questions as well. So feel free. And having this said, Roberto, welcome. Nice to have you here.
Hi, Rita. Thank you so much for having me here. It's a real pleasure to be here today with you. And congratulations for this awesome initiative that you're presenting everyone in the community with having your YouTube channel and all of these recordings and sessions that you're doing every month. I don't know, is that like a monthly event or?
We've been doing it weekly. So, but
okay,
we
weekly.
might have,
Cool.
yeah. So,
that's
but
wonderful.
we might have. It's quite cool. I think we've been building a nice kind of group of or list of content. So hopefully we'll have also you joining that one with sharing your insights. So thank you for
definitely.
that, Robert.
It's my pleasure.
Thank you, Robert. Let's get to business and start your talk.
Yeah, for sure.
Okay,
so yeah, thank you for the quick introduction. Just to complement some of your on my bio. So currently, I work for Red Hat, and I'm one of the principal software engineers over there, and I work a lot with microservices. And one of the microservices technologies that we use is MicroProfile, which is an open source initiative from the Eclipse Foundation. And the idea is try to bring in a little bit of trying to come up with some specifications in the microservices world. And of course, part of my work is also related with Quarkus. So I do a lot of microservices stuff, implementation on Quarkus, of course, on not only on MicroProfile, but also general things. And the talk for today is going to pick some of those topics a little bit here and there. We're going to talk a little bit about Quarkus, a few things about MicroProfile, microservice in general, and of course Kubernetes, because that's what people really enjoy these days. And of course, you have to give what people enjoy these days. Anyway, So I like to make my sessions most interactive as possible. So as like Rita mentioned, feel free to send me any comments or questions during the talk, and I'll be happy to answer them straight away. In the meanwhile, I'm just gonna have like a few slides just to hopefully that's not gonna be too much boring, but for us to dig a little bit into the topics, and then I prepare a couple of demos for you. So hopefully that will go okay. And so let's move on, and let me go and share my screen. Here we go. And let's go present. So I hope that you're able to see the slides, right?
Yeah, we are. It's perfect.
Okay,
Thank you.
wonderful. Yeah, so Quarkus. So let's talk a little bit about Quarkus. So that's the first thing I'm going to talk to you about. So Quarkus is also an open source initiative. The idea is there is a complete full stack technology to write Java applications, and you can build all kinds of applications with Quarkus, either cloud native, microservice, and serverless. So those are the kind of applications that modern architectures try to develop these days. But Quarkus is way more than that. So as we're going to see in the next couple of slides as well, you can still use it, or you can even use it to build your typical monolith as well. So it's not really um, suited. I mean, it's not really like locked into a particular set of architectures. But we believe that the way that Quarkus is built, it's way better to build these kind of stacks when you use our technology. Now, of course, I mean, there are a lot of other technologies in the market, right? So there is probably the most popular one, which is Spring, and then there is others like Jakarta, and we do a little bit of Jakarta as well. But other like full application servers of Jakarta, like Wildfly or Liberty. You have other smaller frameworks like Micronaut, Trapwizard. So there is like a bunch of things that you can pick from, and that's actually great because it means that um, you're not locked into a particular technology, but you have the freedom to choose, right? So the question that you're probably going to ask is, okay, there is all these great technologies around in the community. Why are we going to pick Quarkus, right? Now, the reason why we like Quarkus, and that's one of the main ideas that we have when we started to work on Quarkus, is we have to start and dig a little bit on the past and how the JVM and how containers work, right? So if you're not aware, so I'm not going to go too deep in this, but if you're not aware on how the JVM manage memory, right? So there's always like an overhead of memory when you're loading classes, right? So there is the startup overhead of the runtime code that you're loading. There is the memory overhead of the object that you load, right? And all of this composes of the memory that you use on your application, right? Plus the container. Now, usually this is not a really big issue in the past because you ended up buying like this huge rack server, right? That has like a huge amount of memory, and you usually bought them with additional resources, right? Because you didn't know how much the application is going to scale. So if you had something like a 1 gig application, or maybe not that much, maybe like 200 meg or 300 meg using memory, that was not really a big deal, right? Because all the upfront cost was already paid by you having those additional resources on your backends. Now, when you're moving to the cloud, things become a little bit different, right? Because now you're starting to pay by the CPU that you use, and you pay almost by the byte of memory that you use, right? So any kind of savings that you're able to achieve in that field is going to be a less amount of money you have to pay for a cloud, right? And but then not only that, if you compare the JVM with other kinds of technologies, right? So, and of course these graphics are not at scale. So it's not like you have like 4 hotspot environments. It's going to equivalent to like 8 in Node.js, but everyone always complained that Java is like a heavyweight technology. It occupies a lot of memory, right? And people started to move to other technologies like Node and Go, which are less memory hungry. And by the way, just like as a parenthesis over here, if people complain that Java is memory hungry, just try to look into the memory that your browser uses, and then we'll talk. But anyway, of course, people in the Java community, they didn't want to stand still and just watch people moving to other technologies. It's not that I mean, we love other technologies as well. They also feed into Java very well. But we wanted to give something that developers could use that will use, of course, less memory as well and be competitive with these kind of other technologies that we have in our communities. Now, again, these graphs not to scale, but just for you to have an idea. So if you pick like any traditional cloud native stack, and I mentioned a few in the beginning, so you might be seeing like maybe 200 or 300 meg usage, right? Now, the idea if you use a Quarkus application, it's going to be less memory hungry than any other traditional cloud native Java stack. And there are reasons for that, right? And of course, I'm going to go for those reasons to make sure that you're convinced that is actually true. Now, the idea is that by making Quarkus less memory hungry and less CPU intensive is, of course, you're going to be able to fit more Quarkus instances in the same amount of resources. And if you link that up with one of the reasons that I mentioned in the beginning, right, or at least in a couple of slides, where you have this shift of the cost, where you have now having to pay by the byte at your cloud providers, right? So this is becoming way more important, right? And I've seen it happen, right? So even before me joining Red Hat and working in Quarkus, I was working for a typical product slash enterprise company, right? And we see the difference, right? Where we have like old stacks that were very memory hungry and they were just skyrocketing our cloud bills, and then we started to build some applications in Quarkus, and we see the difference where we were able to either lower our cloud provider costs or just fit way more instances in the same cost that we were fitting the other one. So I think that's a really relevant point. So this is, of course, this is probably like management talk, right? So you can convince your managers, oh, yeah, because of course all the managers like to hear that you're gonna save them some money. But of course, we have to give something to the developers, right? And one of the things that we like to try to give to you is what we call developer joy, right? Now, developer joy is something that we try to make the development environment as much friendly as possible. So we're going to see, and we're going to, of course, make a couple of demos on that so you can see how that behaves, right? So there's like all as well, you have all these reactive trends, right? But the idea is you don't have to go and learn all these crazy reactive APIs. Of course, they are there in Quarkus, but for instance, if you write the REST and the REST endpoint in Quarkus, it can either be reactive or imperative, and you just have to change the dependency to tell which one you want to use, and you don't have to change your implementation code. So it's really convenient. And we also like to joke about this. So most likely, I mean, Quarkus came out maybe I can't remember exactly, but maybe like 2 or 3 years ago, maybe 2 now only. And we like to joke that Quarkus that you probably have more than 10 years of experience with Quarkus, right? Because um, we use like the best breeds of libraries and standards out there in the community, right? So most likely you already seen these technologies before, and you've seen these APIs. So if you want to start coding with a Quarkus application, you don't have to learn a completely new API. So all the old APIs of, for instance, JaxRS or Jackson are available to you directly into Quarkus for you to develop a really quick REST endpoint, so you don't have to relearn any new thing. Now, coming a little bit into details about these, right? So the idea with the developer joy, we have like a zero configuration deployment for you. So we try to come up with all sensible defaults, so you don't have to set up like a lot of things in the beginning for you to start coding. One of the things that people really enjoy a lot is our live reload experience. So you have a development mode where you can just type your code and you basically have instant reload on your application in Java code. Yes, that's correct. Without any additional tool, without any additional setup. It just works, and it works for pretty much every case. All the configuration is at the same place, right? So we try to streamline all the code to be able for you to cover most of the cases with 80% of the API, and then will be a little more flexible with the rest of your use cases, and then you can go into our Quarkus specific APIs to handle those specific cases. And another thing that people really enjoy, and I'm gonna talk a little bit about that as well, is our native executable support, right? We're using GraalVM, so that's really where we also shine, and people really enjoy that. Now, I was talking about memory, so here are some of the measures that we did, right? So, for instance, a traditional cloud native stack may occupy like 130 megs. So usually, a Quarkus one will be like half that size, and if you go with native, it's going to be like a tenth of that. So it's really impressive values. Um, if we compare it with something, for instance, REST plus CRUD, maybe like a couple of REST endpoints, an Hibernate application with CRUDs, maybe like a bookstore or something, then we'll probably see a little bit of increase on the JVM side, on the memory side. Not like a half, but like only like 50 meg less, but still relevant. And again, if we go to native, then we'll see again of like one tenth of the size, which is really, really great. Now, startup time is also a thing, right? So we are developers. We are usually like impatient people. We don't like to wait. And the interesting thing about Quarkus as well is that you get like almost like sub-second startup times, right? So REST application usually starts like in less than 1 second. If you have something like REST, Hibernate, a couple more things, the database takes a little more, but still you don't really have any time to go and change your tab to read the news and come back later because it's only like in a couple of seconds, right? When you compare it to other stacks, we usually take like 10 seconds or more. This is really a big thing. So this is an example of like of a Reactive as imperative, right? So you can still use the same code. You don't even have to use the publisher. You can even use the string. Publisher will give you a little more control, but basically you can combine both worlds, and you don't have to go crazy with these new Reactive APIs. Of course, they're there. You can use them, but at least I think for me, which I'm not like a Reactive expert, it is interesting for me to start using Reactive in this simple way, and then I can, at my time, explore all the other APIs when I need them. Oops, sorry. And finally, so probably recognize some of these logos, right? So you have things like Camel, MicroProfile, which is also part of what we're going to talk today, Kafka, OpenShift, Kubernetes, Vertex, REST Easy, Hibernate, Jaeger. So all of that is supported out of the box. Even Spring. So if you're coming from the Spring world, I know this is a little bit crazy, but you can actually use the Spring APIs in a Quarkus runtime, so you don't even have to relearn any other API. So you can use. We don't support the entire Spring stack, but the most popular ones are supported over there. So you can develop your REST controller with Spring and just deploy it or just run it in a Quarkus runtime, and that will work fine. And you'll still get all the benefits that I mentioned with Quarkus. Now, stop trying to sell in Quarkus and tell me how it works. So yes, so let me tell you how that works. So for you to be able to understand how we are able to achieve all of what I'm saying, right? So if you look on how a particular framework usually operates, right? So you usually have like a build time step, right? That's where you build your code and you generate like a WAR file or a jar file, and then you pass that to a runtime, right? And then the runtime has to go up, open up the jar file, read the configuration, load a bunch of things in memory, do class path scanning to try to find out what are the beans that you have to instantiate, intercept. So as you know, you put annotations everywhere on your code. That adds additional behavior to your Java classes, right? But that is not free. It comes with a price, right? So in the price is the server that and the APIs, they have to scan the class path, they have to look for the annotation, they have to read them, they have to apply the behaviors, and all of that takes time. Um, Usually, like a model is built with all of that. So if you think Hibernate, it has to pick up like the database tables and the entity annotations to build up that schema representation in memory, and then there is where your application usually starts. So most of the times, like you have all of the startup time that's just only preparing the application to be able to receive your first request or your first service to an user, right? And the interesting thing is, if you're running these on 100 nodes, these operations are always the same for all these nodes. So it's basically you're wasting time all the time when you have to restart the node or you're just deploying a new version of your app. Now, one of the things I try to do with Quarkus is we shifted these around, right? And we try to do most of the operations at build time, so at compile time. So for instance, if we know that we're going to have to read this configuration file, we can just read it directly from when we're building the application, and we just build the model directly in build time. And instead, when Quarkus starts, instead of going and having to read the file, it will just read the meta model that we already prepared during compile time, and it's way faster. So this has like two advantages. Not only is faster, but because the code that's used to read the file is not needed anymore, we can just throw it away, and it's going to be less memory is going to be used, right? So I believe that with this explanation, is quite easy to understand why we were able to save memory and also startup time by trying to do most of the operations during compile time and not during runtime. The same thing for class path scanning. So instead of doing the class path scanning during runtime, we do it on compile time a single time, and then we just provide a dictionary of everything that the application may need, and we just create all the instances and so on and so forth. Now, an additional thing that we try to do as well is just we try to remove all the Java reflection around. So we try to not use any proxies, because we do this class path scanning and we know that we have to provide an implementation of whatever service. We can just bytecode generate that, and it's going to be way faster than you just creating your typical proxy with reflection code that you have to call, right? Now, to try to summarize this, so we try to move as much as possible to the build phase, right? And of course, this tries to minimize the dependencies that are required at runtime, right? So if we try to do as much operation as we can in build time, then it's going to, of course, going to be code that's not created for instance, class path scanning. We don't require an API or a dependency to do the class path scanning because we already done that during build time, so we can remove that. And as much if we try to, if we keep removing stuff that we don't need from runtime, of course, we're going to use less memory. So this, of course, maximizes what we call dead code elimination, right? And reflections. And I mean, all of these had a single goal in mind, which was to try to build a Quarkus application in GraalVM and being able to build it as native, right? Now, these optimizations, while they were thinking to be able to done in GraalVM, of course, they also affect hotspot, right? So you can either use it on both Graal or in both hotspot or any other JVM. So it's still valid. But the reason why we went to doing GraalVM, and we're going to have a look into that later, is because there are some limitations, and GraalVM we want to run as a native mode, so we really have to do this before. Now, this is another example. So, right, like parsing config files, the class path and the classes scanning, right? So proxies and reflections. So we try to get rid of all of that, right? And of course, the application is going to be way faster. Now, a couple of other benefits. So because we do this in compile time, we do this work only once and not on each start. So remember when I mentioned when you're running 100 nodes on your cloud provider that you're running the exact same runtime instructions all the time. So if you've done that on compile time, you've done it only once, because basically you just generate your deploy descriptor, you deploy a file a single time, then you just distribute them for all the nodes, right? So all of them can benefit from any work that's been done beforehand, right? Bootstrap costs are no longer needed, right? So if you're reading configuration files that you don't need to read anymore, then you just can throw that away. And of course, that's going to translate into less memory usage and less startup time. Now, of course, there's some magic involved on this, right? So what we have is what we call the Quarkus extensions, and the Quarkus extensions try to wrap like all the libraries that we use. And the idea is that we contain the logic to make the library contained to be able to do all of these that I've described, right? So a lot of extensions we already provide for you, and of course you can make your own. Now, don't get me wrong, you can use any dependency out there from the Java community. You're always going to work with Quarkus because Quarkus still runs on Java. Now, you may require an extension depending on how the library operates, right? So we know, for instance, that Hibernate generates a lot of configuration files and a lot of metadata, right? So we're able to pick the Hibernate and create an extension around it to be able to move all of that logic into compile time. Now, maybe some applications don't need that, and or some libraries don't need that. In that case, you're not going to benefit more if you're going with Quarkus, but they're still going to, you still are able to use them on Quarkus just fine. Now, some people might think that like Quarkus is just a compiler, it's just for Kubernetes, or it's just for the cloud. Well, I think that Quarkus is way more than that, right? So Quark is not just a native compiler, so you can use it either on Java Hotspot, any other Java JDK distribution, or GraalVM. That's fine. Java is not just for REST. You can use it to build any kind of application. So we've seen people using it for writing CLI applications, backend applications, web applications. Just it's okay. It's not only for small applications. You can use them to build monoliths. It's also fine. We also seen that people using Quarkus to run them on Raspberry Pis, because I mean the footprint is so small, and Raspberry Pi is so doesn't have that many resources, so it works very well over there. It's not a copy of Spring. I mean, we love Spring. Spring as it's like a huge technology, and it's a great technology. We don't try to copy Spring. We try to do our own thing, and I think we were successful with that. And it's just not another framework, right? We try to offer you a lot of other things more, and we try to shift around the mindset of developers when they have to develop thinking in build time instead of just runtime. Now, native image. So really quick on native image. So if you're not aware, so GraalVM is it's not only a JVM, it also works with a JVM, but basically it's a project coming from Oracle. And it is a JVM distribution as well, but also provides ways to have this closer world view of your application and pick that up and generate a completely binary file that you can run without the JVM, right? So there's when you generate a binary file, it's not the JVM anymore. It's just like a binary distribution that you can run directly from any from any computer, as long as you build to the right architecture. So if you're like a C developer, you know what I mean. Now, this native application runs in something else, which is called Substrat VM. Also has like a garbage collector, a lot of other things, but it's not JVM anymore, right? So that means there are some limitations, meaning like there is no dynamic class loading, right? People things that the Java loves a lot, right? People like loading and reloading classes all the time. Invoke dynamics not supported, method handlers are not supported, no security manager, no finalizer. So a lot of other stuff they're not. That's not supported from the JVM. Other things that are supported are there, but they have limitations. Like, so for instance, reflection. Yes, reflection is supported, but you have to feed them a manual list of things that you want to call for reflection, right? Because when you GraalVM generated the binary distribution, if we will just assume that you can call anything by reflection, it will have to include all JVM. and that's not the idea, right? The idea is that it will just include everything that the application needs, and that's it. Again, dynamic crossfits are only supported if you list them, right? So there is these kind of limitations, and the idea is that we came up with Quarkus, this basic architecture with Quarkus, where we do everything in build time, remove a lot of that stuff. So then the native image support and image build is way more streamlined than you having to go on all these additional steps of providing all of these. So Quarkus will look into application, provide it for you, so you don't have to set up that yourself. And usually, just with a single build command, you're able to build a jar file or a native application with Quarkus. Now, when do you want to use a regular JVM or native, right? So, for instance, a JVM will always going to be better if you have if you want the best raw performance, right? You have a huge throughput. Still, legit compile is going to be better. But if you have like lower heap sizes, or you will really require fast startup time, so usually a native application is able to start in like 10 milliseconds. So we're talking about serverless or function as a service. So the native image is great for you. And we have users that like to use both. So you just give it a try and see how that works. Now, let's try to do like a really quick demo for you. So now let me go.
Roberto, sorry
Yeah,
to interrupt you.
it's fine.
Okay, but we had a question from Pedro, but I think you mentioned that you just answer it. But let's put it either way because some people might have it as well. So the question is, hi Roberto, and hello Pedro. One question: if you do all the work before packaging, does that make the packages bigger? And I think I already went through that, but just to make it clear.
That's a very good question. Yes, the packaging will be bigger in the sense, but I mean, we're not talking in that big of a deal, right? So what we're trading off is packaging size at the file system by packaging by size at the memory level, and which one is expensiver and which one is the cheapest one. So file system memory is cheapest, right? So, but we're talking about just like a few Ks, right? What we're talking is, okay, we're just going to generate the bytecode for a particular service, right? Of course, there's going to be usage of your file storage. While if you generate in the bytecode at runtime, it's going to be in memory, you're going to use that memory at your cloud provider, right? And that's going to cost you more because memory at the machine level is costly, is more costly than at the file storage level. So basically, there's like a trade-off here. Yes, your package is going to be a little bit bigger, but I don't think the size really matters in this particular case.
Awesome. Thank you, Roberto, and thank you, Pedro, as well, for your question. Go ahead, Roberto,
Okay.
to your demo.
Yeah, so now I have here a quick application. Like this is on GitHub, so there's a lot of instructions over there. So yeah, I can share the link in the end, and you can pick that up and play with it. So this is a MicroProfile application being built in Quarkus. So it's like just like a simple REST endpoint. It's trying to inject a configuration over here, right? And one of the things that I'm gonna do right now. So let me remove this. Actually, okay. Let me just increase my terminal a little bit over there. So this is not, okay, here we go. So that's the terminal that I want. And I'm going to run Quarkus as a development mode, and I run it with like this with Maven. So you can run it either with Maven or Gradle. Doesn't really matter. We support both. And because development mode is going to take a little bit longer to start up, and I mean, having Kubernetes and Chrome and all this slide share is not gonna cut it. But anyway, now I'm running this on development mode, so I can come here to my browser. Let me see where I can go. So let me go over here. So if I go to localhost numbers, so this is basically calling these REST endpoints, generating like a random number. So nothing really that big. big of a deal. So if you go over here, so this is like the a small console that we give to you. So there's also a Swagger UI. So you can check and call the endpoint from here, and that's fine. Now, I can come over here, and instead of generating a random number, I can just say hello x geeks. Hope that's how you write it. And if I execute, now you'll see that what you get is hello x geeks on Swagger. So let me just call the REST endpoint directly. So it was called numbers generate, and there you go. Right? And as you can see, it was amazingly fast to reload. I mean, you didn't even notice. I just came to my IDE. I just make like a couple of changes, and I hit refresh on my browser, and you get the instant result back, right? So it's really convenient. Now, yes, I'm changing line of code. It may be like a simple thing, but these actually support. I mean, I can come over here and add like additional methods, and it's going to work just as fine. So let's actually create like a hello endpoint. I'm just going to implement the method over here, and well, I'm just going to copy this, and I can just revert this one to the previous behavior just to make sure that everything is okay. So let's just reload that. So you get the old behavior, and if you go to numbers hello, was that hello? Oh yeah, sorry, I forgot to add the annotations over here. So let's call get, and let's add a path with /hello. And hopefully, and there you go, right? So it's really convenient for me to develop the application like this, because it's not like I don't have to go and stop the application and have to recompile. I can just do the changes, and I can see them directly into my browser or whatever other media I'm using to debug or see the application. So this development mode is it's really cool. That's one of the things that people love the most, and that's great. Now, before going to the Kubernetes portion, because I'm not really, I always forgot how to use the Spring API. So let me just unshelf things over here. For now, let me just restart. Yeah?
So interrupt you once again. We have a question, which is if you could
Sure.
increase the font of editor, because I think it.
Oh, yes, sorry. How's that?
Okay, I would say it's better.
Okay.
Thank you.
Yeah, so now what I have over here is, let me just re-import that into the browser, into the IDE, I mean. So now what I have over here is like a Spring controller, right? And this is calling greeting, it's called hello again. So yeah, I mean, I need to be more imaginative with the endpoint's name. But if I come here to my browser, right, and if I go numbers greeting, let me see, number resource. Never mind, that's just probably over here, but let's go numbers. Yeah, it's not number, it's just greeting. Okay, so you have hello, right? And let's say hello x geeks again. And there you go. Now the interesting thing that you have over here is just you have like a completely REST endpoint or REST controller using the Spring API, and you have hot reload with that using Quarkus. So I'm deploying like with my Spring API directly into Quarkus. So if you're only familiar with the Spring APIs, you're free to use it, and you can still use Quarkus for that. Now, let me just revert this a little bit so we don't get too many surprises. Sorry. Let's gonna go and roll back that. Let me go and roll back that as well. For now, let's keep that one. And I'm going to stop this one. And now let me just increase this a little bit more. So let me. One of the things I'm gonna go over here now. I'm just going to deploy. So you can see I built like a couple of commands, right? So mvn verify, so it's not a standard Maven command. Quarkus container image build true, and Kubernetes applied true. So Quarkus already comes with these out of the box. And what I'm doing is I'm creating a Docker image for Quarkus. My Quarkus application is going to deploy this Quarkus application into my Kubernetes cluster that I'm running locally. So it only took like 14 seconds, really, really quick. So if I do a kubectl logs, and so number API, so now number is running over there. And of course, if I come here again, yes, that one disappears. But now you may be wondering, okay, I want to do any changes to my Kubernetes pod. Well, you can run mvn Quarkus remote dev. And this is actually going to attach to the remote Quarkus running on Kubernetes. And now you have the exact same experience with the development mode, but now connected to your Kubernetes application that's running over there, right? So I'm not, well, I'm telling you that this works. So I hope that you believe me. But let's try to do it right here. So if we come over here, oops, say not that one. Let's increase this a little bit and say hello x, oops, weeks, right? And now it's not greeting. It's still localhost numbers generate. So it takes a little bit longer to do the reload, right? Because it has to communicate with the Kubernetes cluster, but still it works very well. Now, let me try. So I don't think we have too much time left. So let me try to do this command. It's going to take a little bit longer. So the one that I'm going to run next is, well, just going to probably let me do it like manually instead of searching for that. Is I'm gonna build this into native, right? And so what native is gonna do is gonna look into all the Quarkus application, and it's going to produce a native executable for that application. Now, if you have experience building C applications, right? So it's going to be a similar process, right? So it's not like an application that we generate bytecode and then the JVM interprets that when it's running and then everything goes fine. No, here there is this closed world assumption, so everything has to go over there, everything has to be inferred right over here because there is no other information when you run in the binary after the compile process is done. So naturally, the compile process is going to take a lot of time. Now, ideally, it's not something that you want to build all the time, right? Because it takes, of course, time. Now, one strategy you can use is you have your continuous integration environment or just continuous build, and you just generate the binary image from that. Now you may be wondering, well, I mean, it is a different thing, right? But we try to give you the exact same experience between the JVM mode and the binary image mode, right? So hopefully what you do is you write your Java code, you write your tests, you write everything, and then again, you can just generate the binary. You can run the tests there as well if you like, whenever you want. So you don't have to go for all these process all the time. Now, it's going to take probably a little bit longer because I'm streaming and have Kubernetes running, so it takes a lot of memory over here. So while that is running, let me just show you a little bit of more on the application side. So if you look over here, so as a process structure is really simple, right? So it's just a simple Maven file. Have a couple of annotations, a couple of dependencies over here. We have a BOM file where you can just pick up whatever dependencies you want. We also have one for MicroProfile. And on the POM itself, then you see that we include some of the Quarkus stuff, right? But you also see other things that are not Quarkus related, like Rest Assured. You also see Lombok and Mapstruct from there. And I'm gonna do something very, very interesting here. If I go and do like find path into my source folders and I search for Quarkus, well, the only thing they'll see is like Quarkus in configuration, which is this application.properties file. That's where all the configuration from Quarkus are going to be places. And all of them, of course, follow a structure, which is Quarkus dot whatever extension name you want to configure, and of course, the values that you want. But if you look into the application code itself, if I search for Quarkus, there is no Quarkus reference over here, right? So there is this number API as imports uses the Eclipse MicroProfile APIs and JavaX for REST endpoints, right? And I show you the Spring ones equivalent. So all of these are like config sources, and all of them they don't just use like other libraries APIs. They don't use any specific stuff. We do have these Quarkus test thing, right? So which is somehow equivalent for the one for Spring. So if you want to run Quarkus as JUnit, you say like Quarkus test, and this will instantiate the Quarkus environment for you in JUnit, and it will just run it as like a regular test, right? Now, hopefully the native, oh, it's failed. It's not like, that was just a test, that's fine. But the image should be there. So if I go and say target, you'll see there is like this number API runner is like 63 meg. And I'm going to do something you should never do, which is to attack a cat on number API runner. And now you see, now you probably believe me, this is a binary file, right? So if I go and how do you run a binary file? Is you in a Unix environment, you will have to do dot slash. Of course, I'm going to do dot slash target, and I say number API runner. And this is probably not going to work because I still have my other one running on Kubernetes. So let me just delete that. Okay, there you go. And if I go now target number API runner, now you see is Quarkus running as a binary mode. It started in 23 milliseconds in my box. Usually it takes like 10. But again, I'm on a heavy load over here. And this works exactly the same as the other app. So if I come over here, you'll see, so you don't see much because it's now I compile that with that. Now this is running as a production mode, so it removes like that console, so not a big deal. But again, you'll see that the application is running as an active executable. And if I want, I can also deploy this into Kubernetes. And well, you have like a very small footprint application running in Kubernetes. Now, if I go here into monitor, probably it's like the easiest way to show that, and search for number API. This is like very small. Let me just increase this a little bit. So you'll see that this executable number API runner is only 13 meg in memory, right? So it's very small, and it started very fast. And if I go and let me just do like mcn that, yeah. So this is just like a shortcut to do mven clean install with no tests. Now, if you want to run a Quarkus application, of course, we generate a Java file as well, or a jar file. So let me run the Java equivalent instead of being development mode, which is a little bit better. So you come over here, you have a Quarkus, and target, you have a Quarkus app folder. So you say, java.jar target Quarkus app, and there is Quarkus run jar. And this will run, so you can see now it's a little bit faster because it's not development mode. 1 second. So if I go to monitor again, and I'll search for Java, maybe I have a couple of other Java processes, but if I increase that, now you'll see I have one which is 500 meg. I'm not sure what it is. Maybe it's like the IDE, and the other one is probably this one is 150. It doesn't matter which one it is, but at least you know that it's occupying way more memory than the one that I just run as a binary. So yeah, so these are a couple of things that we're able to do with Quarkus. So if you want to start up with Quarkus, my suggestion is you can come to a website called codequarkus.io, and this will give you can come over here, you can pick up which group ID artifact ID you want to name your project, pick up which build tool you want to use, Maven or Gradle, and then you can just pick up whatever technologies that you want to use. So you can pick up things like REST-easy, gRPC, Hibernate. So there are like a bunch of things over here, GraphQL, Amazon APIs, Camel APIs, the Spring APIs, right? and you pick which one you want, and you just hit generate application. We'll just generate the application for you with some templates, and then you can just go from there. So it's a really convenient way to start coding. Well, I think I don't have much time left, so I can open up for additional questions in the end if people would like to go there. So
Thank you so much, Robert, for such a great overview of these content of yours and these insights of yours. Would anyone like to make questions to Roberto? We're super lucky to have him here. So we have Marco thanking you for a great presentation. So thank you, Marco, not only for attending, but also for this comment of yours.
Thank you, Marco.
Awesome. Thank you. So we have a question actually, Roberto. So
Wonderful.
let's put it here. So will it reload as well if we change application properties? And thank
Yes.
you, Pedro, for the question.
Yes. So we monitor every resource from your application and we load it, right? Now there are some situations where we will not be able to reload, right? So for instance, if you're using like an external library that has its own resources, right? Let's just say a config.properties that only that library knows about, right? So Quarkus is not able to know that that library used that resource, right? So then we're not able to reload. And that's where Quarkus Extensions comes in. So the Quarkus Extensions is one of the other things where you can just say, hey, so we want to do an extension around this library to just tell Quarkus and say, oh, this library has these resources, so please monitor these additional files for changes so we can hot reload the application, right? So because application.property is something that we ship with Quarkus, we already automatically check for that for changes. So other things may not work, but if you still stick with all the Quarkus extensions, then you should be fine.
Thanks, Roberto, for this answer, and also Pedro, thank you for your question. Lucas also is thanking for this presentation. So awesome.
Thank you, Lucas.
And
that's my son name.
That's nice. Oh, that's nice. That's nice. And we actually have another question from Baram. Is it possible to use Java Native on AWS Lambda?
Yes. So if you see when I mentioned like code.quarkus, you see like a lot of AWS APIs over there. So every extension that we ship with Quarkus or that you're able to pick from code.quarkus, we guarantee that you're able to use it as native. Right? It means that we already done the work to remove a lot of the stuff that the library may not support on native, and that's usually what the extensions are all about, right? It's able to do this additional work that we know that is not supported for native. So everything that we put on code.quarkus, it's native ready, and you can use them with confidence that you're able to build them as native. And if you find any issues, then of course, you can open issues on GitHub. So the project is completely open source. We have like a Zulip web chat where you can just go over there and talk with developers directly. And so if you find an issue over there, please let us know and we'll fix it.
Awesome. Thank you, Roberto. And also thank you for your question, Bahan. And we also have Pedro thanking you for the presentation. Pedro also brought some interesting questions to the table. Nice. And last call, do you have any other questions for Roberto? Let's see. While people type, Roberto, thank you so much for joining us.
Yeah, it was my pleasure. And I mean, I know that sometimes the questions only come later. So if for some reason then you try out Quarkus and you like it, please let us know. And if you have any questions, please let us know. You can reach me on my Twitter handle that I think it was already published. It's Rad Cortez. If you prefer, you can reach us on Zulip. So go on GitHub for Quarkus and you search all the community links over there, and then you can put us the questions directly if you prefer. It's completely fine.
Awesome. So we're going to leave again here your Twitter handle so that people can leave their questions or engage with you or even discuss some of these topics. Roberto, thank you once again for joining us. It was awesome having you here. Thank you also to everyone who joined us for another great live stream of ours. I'm a bit biased, but I think it was a great one indeed. And we hope to see you again next week. So take a look at our social media platforms and all of that to be posted on next events. And also, of course, follow Roberto also on Twitter so that you can also keep up with these news as well. So thank you so much, everyone. It was nice having you here. And have a great rest of your week. And thank you as well.
Thank you
Bye,
very
everyone.
much. Bye-bye.